Okay, hello everyone. So this is the recording on uh, last topic on topic 5, and it's the magnetic effects of electric currents. Okay, so before we dive into the magnetic effects of electric currents, we will talk about magnetic field in in a little bit detail first. Okay. Okay, now let us assume we have a bar magnet here, and you all know that the magnet will have two poles. One is the north pole and the other is the south pole. Now, the first task that we're going to do here is to draw the magnetic field lines. So when you're given a magnet and you have two poles, so how do we draw a magnetic field line? So that's our first task. So unlike electric field, the magnetic field curls around itself. Okay, so for example, the magnetic field lines will look something like this with curls. Okay, and the rule is very similar here. No two field lines intersect each other. Okay, so when you're drawing a field lines, you'll have to draw it in such a way that the field lines do not intersect each other. Okay, so this will be the field lines for the magnetic field and something like that. So I could draw more, but let us just stop with this one. Now, this is the way how the field lines of a magnetic field looks. But what about the direction? So how do we find the directions in a magnetic field? Now, this is something very, very important for you all to understand. Okay, so the field lines is basically drawn from north to south. So if I want to draw the field lines of this the bar magnet, then I will have to draw it like this. Okay, something like that. Now, how do I know that this is the direction of the field lines? Now, if you have noticed, we had some rules to draw field lines in an electric field. So maybe let's just discuss a little here. So let's say we had a positive charge and you wanted to understand how the field lines look and in which direction it goes in. Okay. So maybe if this is a field line, then we said that the direction of the field is in the outward direction. And the reasoning was basically that if we put a positive test charge, then the positive test charge would go that side in the direction of the field. Okay, so which is outward because the like charges repel. Similarly, in the magnetic field, we put a magnetic compass. Okay. And what we are saying is we're looking at the direction of the north. Now, where is the north pointing? At this end. So if we put a needle at this end, the north, like, okay, let's say this is the magnetic needle here. This is the magnetic needle. So obviously the north will be pointing towards the outer direction, right? Because the north and north repel each other. So likewise, if you put a magnetic needle here, it'll be pointing this direction. If you put a magnetic needle here, it'll be pointing in this direction. If you put a magnetic needle here, the north will be pointing in that direction. Okay, so basically when we are talking about a field lines, it is the direction where the north is pointing. Okay, so then as a general rule, you can think of the field lines as being directed from north to south. Okay, that's also the second part of the discussion. Okay, so let's move on to the next part of the discussion now. So what about the forces? Okay, so we said that the like poles repel and the opposite poles attract. So in any magnet, when you put it in such a way that the two poles are opposite. So in this case, the poles here are opposite, right? So this is a north pole here, and this is the south pole. So if they are opposite poles, then they tend to attract. So these two magnets tend to attract each other. Okay, that's a general rule of the forces in the magnet. But what if it's like the like pole? Okay, so the other thing is, what if it's the like pole? So let's say instead of north pole, instead of south, I have now the north pole. So maybe the north pole is here, and then the south pole is somewhere here. So if I have like this, then now these are similar poles, right? So they tend to repel each other. So the magnet tends to repel each other. Okay, so the magnet repels when there are, and then when they have a like poles. Okay, so this is basically a force law in the magnet. Now, let us write some definitions of magnetic fields and magnetic field strengths. So before that, let's talk about the field direction of a combined bar magnet. Okay, so let's say I want to draw a field. I want to draw field lines of a magnet that looks like this. Let me just move this a little far away. So if I want to draw field lines for this particular two bar magnets, then my field lines will basically look like this. If you draw an individual field lines, then obviously the field lines would look something like this, right? Because it's curved. Okay, and then it will look something like this. In this case also it's the same. So like this, I will not draw too many field lines because it'll clutter up here. So if I want to draw field lines here, so the field lines in the magnetic fields with opposite poles will basically look like this. Okay, so they will tend to repel each other. And if you're looking at the direction, so the direction is again from north to south. So it will go like this. The direction of the magnetic field lines will look like this. Okay. And something like this. Okay. Now, what if the magnetic fields were, I mean, if they had a like poles, then how would the field lines look? So let's look at that. Okay, so let me just draw the field lines where it's like charge. So let me just move this slightly up here. Okay, so now I have my opposite poles facing each other. Okay, so if I have this, again, the same thing. You draw a field lines that looks something like this. Okay, looks something like this. And here also it will look something like this. But now the difference is that the north and the south attract each other. So basically, they will have a field line that might look something like this. Okay, now excuse my drawing here because I have intersected this one. So this, I shouldn't have intersected this one. And it would look something like this. Okay, so if you look at the direction here, it would maybe look something like that. If you have two unlike poles facing each other. Okay, so this is how it will look. So I hope it's clear here that when you have the unlike poles facing each other, then you will have a field lines that's towards each other. Okay, so I mean to say that if the field lines directs from one pole to the other pole, and in such a way that it's always from north to south. Okay, so this is it about the field lines. Now let us talk about the magnetic effects of electric currents.